Hey Techno Studs, in this video we're going to do a layer 3 refresher. In the rest of the module we're going to be getting into wide area networks and we're going to be talking about routing and how to do some static routing. But before we do that, let's do a quick refresher about that layer 3 so that way we have a good basis going into this module. Hey Techno Studs, in this video, we'll start out by talking about the OSI model and taking a look at where layer 3 falls within the model. Hint, it's in the name, layer 3. And then we're gonna get into layer 3 characteristics, some of the characteristics that we see that we get out of layer 3, what it's responsible for. Then we'll get into an IP header and take a glance at that IP header, and we'll wrap this up by talking about routers, routes, routing tables, and a few of those other layer 3 concepts. Within the OSI model, layer 3 is in charge of getting the data from point A to point B, to routing the data, to forwarding the data to its final destination. It's built for speed. So let's take a look at this. This is the OSI model, and up until this point, the data is getting changed and ready for that transport. So in the first few layers here, we're just making some changes to this data for this transport and getting it ready to be viewed on the application on the other side. It's sending it essentially from application to application. And so it's getting this data ready. Now what happens at layer 4 is we start chopping it up into smaller sections so it could be efficiently transferred from point A to point B. And it's got to know how to reassemble that when it gets to the other side. And so we add some data about reassembling, and there's some other pretty key characteristics of this transport layer. We call this the segment. This segment gets handed down to layer 3, and now layer 3 is in charge of how is it going to get from point A to point B. And it uses IP addresses for that. IP addresses are a hierarchical address, so that way it can route this packet from point A to point B. And so it adds this information at the beginning of this, and this is essentially then creates the packet that's going to remain the same between point A and point B. There's not going to be a lot that's going to change along the way. There is a couple things that do change, like the time to live, and perhaps it goes across some different networks that do make little alterations to this, but for the most part, it stays intact during the whole distance that's transferring from point A to point B. And then it gets passed down to the data link layer. The data link layer is just so it can get transported on the local area network, on the local network. And so because it's just local, this information on the data link layer and the physical layer gets rebuilt over and over again as it traverses across all of these different networks. So we're going to take a look at this again, but just remember that the network layer resides right here, right on this layer 3. We call it the network layer. It consists of some protocols such as IP version 4, IP version 6, and ICMP. Think ping when you think ICMP. That's one of the components of it. So that is the packet. And let's take a look a little further in depth into the packet and how the packet gets it across from point A to point B. Some characteristics of layer 3. Well, first of all, it's connectionless. That means there's no connections that are established. There's no setup. There's no handshake. There's nothing that is going to be built between these two connections. That happens at a higher level. It doesn't happen at this layer 3. It's really built for efficiency. Like it just wants to get it to its final destination in an efficient manner. And so it doesn't do anything like if it drops a packet, it doesn't really send back a notification, hey, I'm dropping this packet. It doesn't really send a lot of information back so that things can get retransmitted. Once again, that's reliant on other layers in here. So it is what's considered best effort. Hey, I'm going to give this a try, but if it fails, then I'm not going to really reattempt anything. So, and it is also media independent. So that layer 1 and layer 2 can change along the way. So this right here is an Ethernet LAN right here. This could be maybe a T1. This could be a serial, some sort of serial connection. You know, along the way here, along its path, it could run across different types of networks to get it to its final destination. That's the layer 1 and layer 2 can be changing along the way. But once again, the layer 3, for the most part, the packet is going to largely remain untouched to get from one point to the other. Now, how does it get from one point to another? Well, in some of the older systems, like our telephone systems, we would actually make a physical connection from point A to point B. So when you were calling up on the phone, it would actually make some sort of connection between one system and another to get from this point to this point, a line of communication flowing across it. So that is circuit switch. So that's what we call circuit switch, where there's actual circuits that are being connected from one point to another. A lot of our communication nowadays, when it comes to data, though, really happens with this packet switching. So the idea behind packet switching is that we chop this data up into smaller pieces of information, and then those pieces of information get sent across from this, let's say it's this computer to this server right here. And then each of these routers will make a decision on its own on which path it's going to take. And each of those packets could be sent a different route every time. So maybe there's a connection across here too. So maybe there's 3 packets that go from this machine right here to this server right here, and it could take 3 different routes to get over to there. And so this is packet switching, that every packet that comes across here is sent in a different direction, and therefore it could actually be received at a different time as well. And so there's quite a bit of nuances in how this happens, and there's also some pros and cons from circuit switching to this packet switching. This packet switching really does opens up a lot of possibilities in how we transfer data and make these different connections. So since we are trying to get it from one location to another, we have to use things like IP addresses. This is the IP header. So this is what gets added to the front end of the data, so that way we can get this data going across from point A to point B. And some of the information that we find in here is like the source IP address, where it's coming from, and the destination IP address, where it's heading to. We have things like the time to live, so that way if for some reason one router thinks it should go this way and it gets over there, and the other router thinks it should go this way, and it just creates this loop. Rather than bring that loop down, we have a time to live that counts down to terminate that packet and not continue to loop that packet. We've got some other pieces of information in here as well. I just wanted to call out this IP header as a form of reference of this is what goes at the front end of the data, so that we can transfer from point A to point B. So how does this happen? Well, we have routers that will route this information. So each one of these are the routers that is going to route this information, and these routers use routes to figure out where it's going to go. So it stores these routes in a routing table. So this is a routing table that will have a series of routes within it. And so when a packet comes into this router, it will take a look at what is the destination network of where it's trying to go to, and then look it up on the routing table to see what is the best next hop. Where is the next best location for it to route to get it there? Then this router does a similar process to look at its routing table to look up the route, and then send it to the next best location. And then this router says, hey, this is directly connected, so I'm going to send it to this machine right here. So that is routers, routes, and routing tables. We have this idea of next hop, and that is, what is the next best location? So if this router determines that to get to this server right here, the next best hop would be this router right here. So that's the next hop, the next location where it's going to be sent. And each of these routers may just make a simple determination of what is the next best hop. When it's looking in the routing table, it's looking for what is the best route. And it does this by longest match. What is the best match? What is the longest match in the routing table? Because there could actually be multiple entries within the routing table that meets the needs of whatever is the next hop for this packet that's going across there. So it's going to look for the longest match in here, and we're going to get much more in depth into this longest match as we go through this module. Of course, somehow we need to populate this routing table right here. So one of the jobs of a router to do is do route learning, to discover new routes. And there's a few different ways that it can do this. We could statically set up these routes on the routing table. It does learn of some routes just by the way we configure this router. We set up these directly connected networks, so it'll automatically put that into the routing table. And then also we can tell it to dynamically learn different routes to these different networks. So we could set up all of these routers to be able to communicate back and forth to one another. They will then transfer data that will populate these routing tables. And so that information gets passed around, so that way each one of these routers becomes aware of each one of the different networks along this path, on all of these different networks. We call this the dynamic routing protocols. Dynamic routing protocols allows that communication between these different devices so that each of these devices learn of all the different routes. So that is a dynamic routing protocol that also we'll take a more in-depth look into these dynamic routing protocols. All right, so that was a layer 3 refresher of just how layer 3 works. Now we're going to start applying that to the WAN and seeing what it looks like in the WAN and get more in depth into each one of those concepts. So the next few videos, we're going to get further in depth into that. In this video, we talked about the OSI model. We took a look at some of the layer 3 characteristics. We took a look at the IP header, and we wrapped it up by talking about routes, routers, routing tables, and some of the concepts between how routers will actually work.